Welcome to the frequently made mistakes for assignment 4. As you can see, we're going to try a slightly different format using the Zoom feature that records the video on my computer. So with that said, let's go ahead and share the screen and we'll launch into the analysis of frequently made mistakes for assignment 4. So first and foremost, please make sure that you will document your code. I know I say this every time, but people still seem to be making that mistake. So make sure you document your code thoroughly and make sure you explain what's going on. This is particularly true in the acquire method in the Palantiri Manager, which is the trickiest part of the assignment. You'll also note that I'm only focusing my reviews on the assignment 4 portions that deal with the stamped block fair semaphore manager. I'm assuming that you have correctly implemented any of the mistakes you had with assignment 3, which were the reviews I had given you before. So I did not re-review that part of your code. If you're still having problems with any of that code and need me to give you some tips, don't hesitate to reach out and I'll be happy to set up a Zoom session in order to talk it through with you. So now let's get on with some of the key problems that I saw when I looked at the code. First and foremost, lots of issues with the acquire method. This is fairly subtle, and I strongly encourage you to go back and rewatch the video that I did on stamp block. In fact, there are several videos on stamp block, but look particularly at the one where I walk through the conditional write lock implementation, because that looks at the Java documentation for stamp block and analyzes the way in which they apply these features in the context of an interesting example. And that example is very, very similar to what you need to do here in the context of the acquire method. So let's take a look at some of the problems I saw. First and foremost, make sure that you acquire the semaphore first and then acquire the lock as a read lock. Don't do it the other way around. I think you'll get an error saying that you've got the protocol backwards, which you would. So make sure you do it in the right order. Also, down here, make sure that you use the proper syntax to define your iterator object. There should be something in here. This is a generic interface, and so you have to say what type you want to be iterating over. And so look carefully at what's returned from entry set, and it should give you a tip as to what you need to do. If you do this properly, if you put in the right types here, then you don't have to worry about casting the result of next on the iterator in order to be able to get the right type. So that should also give you a big hint as to what you need to do. Couple things, a lot of weird problems people had inside the acquire method. One is that you don't need to be checking to see if there's any true values. You'll discover that soon enough when you go through the loop. So you don't need to use contains true at all. That's just completely unnecessary. The code down here is attempting at trying to do a clever solution using the Java 8 streams features, but it unfortunately is not fine-grained enough. And so what this code is doing is it's trying to upgrade to a write lock right away, and then it goes ahead and does this call. Well, this will work if you get the write lock, but it's way more overhead than you need because we're grabbing the write lock too soon. What you want to do is first acquire the read lock, and then you want to use a subset of the code shown here in order to be able to create a stream from the entry set of the map, which we have here, filter out entries that are in use. In other words, we only want to take the ones that are available, not the ones that are in use, and then find the first available Palantir. And you can do that with a combination of stream and filter and the find first terminal operation. And once you've got that, then you can go ahead and upgrade to the write lock. And with the write lock held, you can do the rest of the logic. So this is too much code being done with the write lock held, which we don't want to do. Let's take a look at some other problems with acquire. A lot of problems with acquire, as you can see here. So one of the problems here, it's not strictly a problem, it's just replicating code unnecessarily. So this code comes through, unlocks the lock for reading, reacquires the lock for writing, and then goes ahead and kind of hard codes the search for the value. You don't have to add that code there. Instead, just let the loop around again and go ahead and it'll do it. And now this time, of course, the write lock, the conversion to the write lock will occur without a doubt because we've got a write lock. And so you can skip all this duplicated code. Let's take a look down here. So this code actually never did anything with the read lock held. It just immediately converts to a write lock. And that's completely missing the point of why we're trying to do stamp lock and why we're trying to do conditional write locks. the whole purpose of a conditional write lock is to try it with the read lock held first, and then when we need to, try to upgrade to the write lock. But we want to try to do as much as we can with the read lock held, because that's obviously going to have less contention than the write lock. Likewise, this code misses the whole point because it's using the key set and the replace method. That key set replace method thing worked great when we were doing the concurrent hash map Ferris Semaphore Manager implementation. But now that we've got an actual lock using the stamped lock, and now that we've gone back to using the hash map instead of concurrent hash map, there's no point in doing this. It's actually inefficient at this point. Now let's go ahead and take a look at some other problems here. Once again, you don't need to use the contains value. You can just do the loop, just do a while forever loop. I should also make it clear that there's some code here that I'm not showing that's doing the acquire of the semaphore. And then down here, a lot of people did the following. And I'm not quite sure why, because I thought we've talked repeatedly about the trade-offs and the benefits of entry set versus key set. So for situations like this where we have to look at every element, or potentially look at every element, we want to use the entry set, not the key set. And then once we've got the entry set, then we can use the set value method here instead of using get, or the get value method here instead of using get, which is much more efficient than having to do the get call each time, which requires another hash lookup. This way we can just iterate through the entry set through the iterator. So it's much cleaner. Likewise, don't use replace here, use set value and get key. And then don't use unlock read. This makes no sense at all because we've just successfully converted to a write lock. Why are we turning around and then unlocking it as a read lock? That makes no sense. So think carefully about what you should be doing. In fact, you should be able to pull the unlock method out of this if-else statement altogether and put it in a finally block and use the unlock version to unlock it, whether it's a read lock or a write lock. I'll let you kind of puzzle it out. It's important to think about how that works. And then I'm not sure why a few people were trying to use the as write lock method. That does not acquire a write lock. It just gives it back as something that is treated in the context as a write lock, but it doesn't block waiting to get the lock. So instead of doing this, you need to use the write lock method to get the lock as a write lock after first unlocking it as a read lock. Yet more problems in acquire. So down here, this is an interesting problem. I'd love to know what the code looks like when run through the unit test. It probably gave crazy results. This code is not caching the value that comes back from next on the iterator. So as a consequence, it's every time next is called, it's going to give the next element to iterate over. So first it's going to get the next and check the value. Then it's going to get a different entry set and set that value. And then it's going to get yet a different version and return that key. So I'm sure that this is not going to be passing the unit test. So think carefully about that and make sure that you store the first value of next so you don't need to make any more calls to next, because it increments the count or increments the iterator to get the next item each time. The bulk of the problems were in acquire. There were also a handful of problems in release. Make sure you use the stamped lock. That's kind of the whole point of the assignment, is to learn how to use stamped lock correctly. So don't not have a lock in the release method. Especially if you put a lock using stamped lock in the acquire method, make sure you follow through and use the release lock, the unlock method for unlocking the stamped lock in the release method. And you'll have to lock it first and then unlock it correctly later. Also, don't fall back into bad habits. Always use the try finally blocks when you're dealing with unlocking locks. Just a good habit to get into. You'll thank me later in your career because you just won't make mistakes with things exiting prematurely. Make sure that you don't call release until after you unlock the lock. So that needs to be setting a flag, and then you move that to below the lock. And then also here, make sure that you use unlock write instead of using unlock, because we know it's a write lock. We acquire it as a write lock. We're not doing any lock upgrading, not doing any lock downgrading. So we need to grab it as a lock, and then we'll use unlock write on it. And then also make sure you move the check to after the lock is released. So those are the common problems that I saw in this assignment. Shouldn't be too hard to fix most of these things. Try to get them done in the next couple of days. That'll give you plenty of time to study for other finals, study for our final, And also, as I mentioned before, if you have any questions whatsoever with respect to what you need to do for assignment three's portion of the FAIR semaphore that's used in assignment 4, make sure you ask me as well. And finally, please make sure that your program passes all of your unit tests, not just the latest ones, but the ones going back to the very beginning. So to get 100%, which you should aspire to, make sure you can pass all of the tests. So with that, I will go ahead and stop my screen sharing. Hopefully this format is a little bit more personalized than just having me doing a screencast. And if you have any questions whatsoever, don't hesitate to reach out. So thanks very much. I appreciate that.